Good morning. I'm Ned Sullivan, president of Scenic Hudson, and I want to welcome you all and wish you a happy spring day. It's beautiful here in the Hudson Valley, and I hope it is wherever you are. For those of you who might be joining us for the first time, the Northeast Carbon Alliance, or NECA, brings together farmers, land managers, scientists, and public policy experts to advance the great power of natural solutions to combat climate change. From mountaintop to ocean floor in the Hudson Valley, New York, northeastern states, and beyond. We're here together because we understand the urgency of tackling climate change as a regional and global crisis. The escalation of destructive hurricanes, tornadoes, floods, wildfires, and rising temperatures are pushing human systems and wildlife beyond their ability to adapt. But there are promising developments that give us hope. The Biden administration has taken steps through the US Department of Agriculture to transform America's food systems to be more sustainable, resilient, and accessible to all communities, beginning to reward producers who use climate-smart agriculture and forestry practices. We at NECA are committed to sharing the results of this shift in policy at the federal level and to work to embed it in the next Farm Bill in the coming years. Here in New York, Governor Hochul has signed the Healthy Soils Act, proposed by our Northeast Carbon Alliance public policy leader, Assemblymember Dee Barrett, as well as Senator Michelle Hinchey. And the bill was advanced through the legislature and the executive chamber and the governor's signature through the great work of Andy Bicking, our public policy and director of government relations, and other NECA partners and others beyond NECA. And we're really happy that Governor Hochul has proposed significant increases in funding for the Department of Agriculture and Markets, climate smart farming programs, and for soil and water conservation districts that can become the frontline sources of technical and financial assistance for farmers and land managers shifting to regenerative practices. And if you're a New York resident, it would be great if you would let your state legislator or the governor know you support these budget priorities this week, because we're in the final 2 weeks of the budget process here in New York. But in addition to agriculture, forest management is also a crucial climate mitigation tool. Forests regulate ecosystems, they protect biodiversity, they store carbon, they help to stabilize the climate through all these processes. They offer many other benefits, including clean water, clean air, habitat, recreation, wood products, and the beauty around us. So I'm really excited by today's virtual program at the intersection of biodiversity, habitat, connectivity, and carbon. So I want to thank and welcome all of our presenters today for sharing their expertise on these important subjects. I'm pleased to announce that Heather Eckert is now devoting her energies full-time to be the project manager for the Northeast Carbon Alliance. Many of you know Heather. She's got a degree in agricultural science, and she's played an invaluable role in helping establish the Alliance's critically important work, and she will continue to manage its operations, coordinating the work and the findings of our member scientists, our research farms, and our public policy partners that will, all of whom will advance our shared goals. So congratulations, and thank you, Heather, for your important work. I also am excited to announce that Scenic Hudson's new Director of Science, Climate, and Stewardship, Pia Ruisi-Besares, will be making formal introductions of each presenter and facilitating the Q&A sessions between presentations. Pia recently joined Scenic Hudson. She's a forest ecologist by training, formerly a project manager at the University of Vermont's Forest Ecosystem Monitoring Cooperative. She has a master's degree in natural resources and environmental management and has coordinated community forestry programs with a focus on urban tree ecology. So welcome, Pia. And I also want to acknowledge and welcome Pete Lopez, who's recently joined Scenic Hudson as our Executive Director of Policy, Advocacy, and Science. He's most recently been with the New York State Department of Agriculture and Markets, working specifically on the Climate Action Council's work in agriculture as a climate solution, and previously served as the U.S. Environmental Protection Agency's regional administrator and a New York State legislator. So welcome, Pete. I want to thank our Scenic Hudson board members who are here with us today and play such an important role in supporting and leading our work. So just a few housekeeping notes before we begin. Please stay on mute for the program unless you want to speak. And the program is scheduled to last for about 2 hours, and we're going to have a 5-minute break. And after each presentation, we invite you to ask questions in the chat, and Pia will be helping facilitate some dialogue and interaction with our expert speakers. So once again, thank you for joining us, and I hope you enjoy the program, and I'll now turn the program over to Pia.
Hi all, thanks so much, Ned, for the intro. I'm very excited to be here and introduce our topic today. So as Ned mentioned, we're going to be looking at carbon relationships through a slightly different lens today by exploring the links between biodiversity, habitat connectivity, and carbon sequestration. And specifically, we're going to be talking about carnivores and herbivory, and also how landowners can be compensated for management actions that promote these goals. So just to do a little bit of context setting before we jump in, as many of you know, and will definitely be hearing about today in these talks, the future of northeastern forests are endangered by a severe lack of regeneration. It's one of our biggest challenges. This happens for a number of reasons, but particularly there's an extreme impact of vegetation from herbivory, from the growing deer population. So impacts from deer browse, for example, create loss of seedlings and saplings, they damage the understory, and they highly limit the growth of new trees that would sequester and store carbon. So today, with this sort of background, we'll hear 3 presentations that address this issue at different levels. The first will highlight the importance of promoting natural predators, specifically carnivores, and habitat connectivity as a means of controlling deer populations. Our second talk will look at long-term impacts of active deer management and direct impact on regeneration on a large piece of land in New Jersey. And our final presentation will pull it all together and shed light on practical actions that can be implemented by landowners to increase forest regen and health for economic incentives. So let's begin. Our first presentation is a joint presentation by Dr. William Schuster and Peter Karis, and they'll be talking about predators. Bill Schuster has been the executive director of Black Rock Forest since 1992 and has overseen Black Rock Forest's development into a biological field station of national significance. He has led a successful effort to build award-winning Green Campus and steered a capital campaign which raised over $7 million in operational and endowment funds. And under his leadership, the organization has grown to support 200 consortium member institutions with more than 13,000 student visitors per day in the forest each year and up to 100,000 public visitors annually. Bill's research interests focus on forest health and growth in relation to the environment and long-term ecological connectivity and sustainability. And Bill currently serves on the board of the Hudson Highlands Trust and is a non-board member of Scenic Hudson's Science Committee and also serves on the Storm King Art Center's Landscape Committee. So great background there. And co-presenting with Bill today is Peter Karis. He is the vice president for Parks and Stewardship at the Open Space Institute, and he oversees all of Open Space Institute's park improvement projects and land portfolio management. Peter is a New York State registered landscape architect with over 25 years of experience in land planning and design, and he has special expertise in parks, recreation, and conservation infrastructure. In the past, Peter has also served as a local planning board member and trustee at Springside Landscape Restoration in the city of Poughkeepsie. So please join me in welcoming them to hear their talk today called Reconnecting for Wildlife and People in the Hudson Valley.
Well, thank you very much, Pia and Ned, and thank you all for being here. And I will start up my presentation. Okay. This talk is about ecological Reconnecting project that developed out of some of our work at Black Rock Forest over the past few years, and a collaboration with the Open Space Institute and other key partners. The project has an aspect related to carbon sequestration, as Pia alluded to, and that's why we're asked to present about it. I'll give background and explain the forest carbon connection, and then Peter Karis from OSI will give more detail about the project. Our third author is Dr. Scott LaPointe from Black Rock Forest, who's been leading the relevant wildlife research. First, regarding carbon storage, Black Rock Forest represents some 4,000 acres of the Hudson Highlands, where tree growth has been recorded consistently for nearly a century. By studying tree carbon content in relation to size, the record lets us track forest carbon and annual carbon sequestration over time. This graph shows above ground carbon content per hectare, averaged over 11 plots over a recent 13-year period. Black Rock Forest contains an average of about 125 metric tons of carbon per hectare in the above ground parts alone, or an estimated more than 200 metric tons of carbon per hectare total when roots and soil are combined. Despite ups and downs, including tree mortality, our region's forests are generally continuing to add large amounts of carbon almost every year. On these plots, that's an above ground average of 1.6 metric tons of carbon sequestered from the atmosphere each year, or a whole ecosystem uptake of around 2 metric tons of carbon per hectare per year. But this substantial uptake and storage will not be sustainable unless these forests can regenerate. Regeneration, small trees replacing larger trees, especially after disturbances, is essential to maintain carbon sequestration. But Black Rock Forest records and a host of others around the region, such as this 2020 map produced by the DEC, show that regeneration has been failing to establish, particularly in the lower and mid-Hudson regions, especially the area in blue and tan. This has been blamed mainly on unusually high deer densities, as Pia said, over the past decades, as deer experienced great conditions in the 20th century for population growth, but almost no natural predation. How do we know deer are responsible? Well, white-tailed deer depend on woody browse close to the ground, thus including seedlings, to survive through the winters. And constructed fenced deer exclosures have consistently resulted in more regeneration inside fences compared to outside, especially under canopy openings. In fact, constructing large deer exclosures and maintaining the fences until the trees grow taller than the deer browse limit is the main way we at Black Rock Forest were able to maintain some regeneration through the 1990s and 2000s. This graph shows deer population per square mile over the last 70 years. The 70s and 80s saw the highest deer density in Black Rock Forest records, some 30 deer per square mile, and huge year-to-year fluctuations. The 90s and 2000s saw some reduction in average deer density, but still essentially no successful regeneration in the understory. But after about 2007, densities came down to about 15 deer per square mile, not just in Black Rock Forest, but in many surrounding forests, including West Point Military Reservation and Sterling Forest State Park. And since then, we have finally been seeing some return of forest regeneration. This new tree regeneration is most noticeable in places with canopy tree mortality. The small ankle-high seedlings previously browsed to the ground by deer have been able to grow into saplings and young hardwoods. These are mostly fast-growing early successional species like beech, maple, and tulip poplar, but with some oaks and hickories coming in as well. So what are the reasons for lower deer densities and the return of tree regeneration? Some evidence points to successful deer management through hunting programs, as shown in a recent paper by Kilpfeffer et al., and a data set recently collated by the Hudson Valley Environmental Monitoring and Management Alliance. But many of us have been trying to reduce deer numbers through hunting programs for a lot longer than the last 15 years, and hunter numbers and hunter pressure have also been declining. Another factor may be the slow maturation of our region's forests, since a dense forest cannot support as many deer as a young forest. But the ubiquity of disturbance, even in these aging forests, and the fact that maturation occurs over decades to centuries argue against this being a primary factor. We believe increased predation by native carnivores, whose populations previously crashed and have recently rebounded to some extent, is a third important factor, such that a degree of natural top-down trophic regulation has been restored. Bears, for example, were formerly completely extirpated from our area, but have returned and significantly increased in numbers in recent years. While omnivorous, bears will occasionally take deer. A recent paper by Karis et al. Attribute bear predation on fawns to growing densities of bear populations compared to other predators in the East and the Midwest. And another recent paper by Boone, shown on the right, placed fawn decoys in forest settings and recorded nearly 90% of bears approaching the decoys and often attacking them. Coyotes were also formerly extirpated from our area, but are probably part of the deer predation story. They are opportunists and have proved quite adaptable to human-dominated landscapes, having returned to our region abundantly. Their predation is probably mostly on fawns too, but 18 months ago, Dr. LaPointe recorded this dramatic video of a coyote taking down an adult buck. Plus, a 2019 undergraduate thesis done at Black Rock Forest found identifiable deer tissue in 70% of coyote scats that were collected throughout the year and not just in the spring following fawning. Finally, bobcats too, while not abundant and probably never completely extirpated from the area, also sometimes predate on deer. In January, Dr. LaPointe came upon this carcass of a 2-year-old, otherwise healthy doe, buried in the snow in an area of high bobcat activity, and he documented wounds on the carcass consistent with bobcat killing behavior. And then he recorded a cat coming back in the middle of the night, which it did several times to feed on the deer. So, can we count on restoration of carnivores and trophic balance at a level that ensures deer population control, forest regeneration, and future forest carbon sequestration? Well, probably it will depend on how heavily developed and fragmented any particular area is, and whether connectivity can be sustained over the long run. Without connectivity, it can be difficult or impossible to sustain effective populations of these essential predators over the long run due to their very large home range needs. All animals need to move to fulfill their basic requirements of life and exchange genes with others. Black Rock Forest's 4,000 acres, shown in the upper right here, may seem large, but in fact, it's not large enough to sustain several of our important species, especially these carnivores. The results here in blue and red show Scott LaPointe's recent GPS collared tracking studies of 2 individual female bobcats show that their home ranges are about the same size or larger than our entire forest. Now that's females. Male bobcat territories are several times larger than that, and Black Rock Forest is also not large enough by itself to contain the range of a single male or female coyote, and is way smaller than the range of a single bear of either sex. To sustain our larger wildlife, we need to ensure that they have safe connections to surrounding habitat areas of sufficient size, and especially maintain or reestablish connections between core habitat areas. And I ask you to remember this, the geography of this slide. On the left, we see the thruway going north to south between Black Rock Forest and Scudamounk Mountain. To the right, we've got Route 9W going north and south, and the Hudson River. Our region's wildlife have great core habitat areas, but appear to be hemmed in by a fragmented landscape between areas of high human development and busy highways. To the north, the densely developed cities of Newburgh and New Windsor represent a significant barrier. To the east, suitable forest habitat exists in Storm King State Park, but is separated by the 4-lane divided highway State Route 9W, which has a solid concrete median barrier. And of course, the Hudson River is a barrier, natural barrier to many species to the east. Just west of Black Rock Forest, suitable forest habitat exists, much conserved by the Open Space Institute. But west of there, the New York State Thruway, with its heavy year-round traffic, clearly represents a challenge to terrestrial animal movement. If our essential carnivores cannot connect with suitable surrounding habitat and interbreed with others, it's going to be a challenge for them to survive, especially with mounting pressure from our warming climate to move northward. The effects of fragmentation for 2 species, bobcats and fishers, whose attempted recolonization of the area Scott has been working to document, can be seen on this image. Camera trap images of bobcats, shown in orange, found them moderately common in the middle around Black Rock Forest, but seldom west of the Thruway on Scudamounk Mountain. Fishers, shown in pink here in a few spots on Scudamounk Mountain, have still not been documented in or around Black Rock Forest, nor on the West Point Military Reservation to our south. Scotts concluded their recolonization to the Black Rock Forest area has not been successful, with highways a likely barrier. And interestingly, neither species was recorded in any camera trap images taken in Storm King State Park to the east of Black Rock Forest along Route 9W. And mortality on Route 9W has been shown to be especially bad. Okay, so that's some of the background on our project that Peter will now tell you about. In our case, it's not just about carnivores and keeping their populations at a level enough to sustain our forests and carbon sequestration. It's also about maintaining as much as possible all of our biodiversity over time, allowing wildlife to respond to our changing climate, and about people too, enhancing human connectivity and reducing the numbers of collisions with wildlife on our roadways. In this, our mission overlaps substantially with the Open Space Institute, who recently advanced the ambitious Hudson West Regional Trail Plan, and with whom we've been working quite closely. So I'd like to now introduce Peter Karis from Open Space Institute to take over.
Thanks, Bill, and to everybody on today's call. And I just want to say that Black Rock Forest has been a driving force during the early design process of the project we're going to discuss, and we're having a lot of fun doing it. So thanks, Bill. If you could forward the slide. Bill's my driver here. For me, this started in 2019, where OSI, working with New York State Parks and other partners, led the development of the Highlands West Trail Connectivity Plan, which was a series 21 trail development and improvement projects intended to provide new and better connectivity between the 6 state parks, 4 long distance trails, and other protected lands in eastern Orange County. And from a broad perspective, the project site that we're looking at, as Bill mentioned, is centrally located in the Hudson Highlands Core Natural Area, shown on this underlying map by the Wildlands Network, with potential connectivity to the northwest towards the Shawangunk and Catskill Mountains. Next slide. More regionally, the project site is located on the New York State Thruway, which is also Interstate 87, south of Newburgh, New York, in a robust area of human development, transportation, land conservation, and visitation. And some key statistics that we've been working with include there are over 65,000 deer vehicle accidents in New York State on average every year, with a cost of over $280 million. And over the last decade, Orange County has reported the most deer vehicle accidents in the state. This site sees over 18 million vehicles pass by it per year, averaging 1 vehicle about every 1.7 seconds. And also over 4 million visitors use the region's robust park and trail system annually. Next slide. Although the concept of a bridge of land over a major highway for wildlife purposes is a relatively new idea to us here in the eastern US, there are varying examples in similar locations across the Western US, Canada, and Europe. And as part of our concept development process, we took a deep dive into many of these precedents to distill common factors that measure success, to inform the concept and build support among New York State Parks and the New York State Thruway Authority. And we also conducted a detailed assessment and regulatory review to uncover any and all site constraints that would impact the design of a crossing at this location. And here you can note the existing condition types on each side of the crossing, and also highway geometry, topography, surface hydrology, habitat, and anything that would influence the placement of a structure. Next slide. Again, I talked about the precedents here. We can go to the next one. Ultimately, we selected an arch with beveled ends concept as it provides some distinct advantages from both the highway design and a wildlife crossing perspective, including efficiency in construction, strength to size ratio, flexibility to support vegetation, and aesthetically, as you'll see shortly, the beveled edges nestle this crossing seamlessly into the landscape. From the wildlife, hang on. From the plan view, the crossing works just like any other bridge and has been sized to accommodate a future 3-lane increase in highway width. And at 200 feet wide, permits about 180-foot wildlife corridor. The crossing also includes a forest canopy, shrub edges, open meadow, and depressed pockets to hold moisture. Next slide. And an illustration, the intent is a seamless transition. Important to the success of being a shared use crossing and controlling the human component, you'll notice the proposed Highlands Trail, which is one of the major regional trails in this area, coming in steep from the north, crossing tightly over the structure through a controlled corridor, and then leaving sharply to the north again. And all of this is intended to provide wildlife with the most amount of room and protection as possible. Next slide. There we go. In perspective, it all really comes together. Again, the habitat corridors, the human route, the highway geometry, and the surrounding landscape. Next slide. And then a little closer, you can even see the bridge in action, start to notice details like stone walls and fencing, and actually deer crossing the bridge. From the highway user's perspective, the crossing reads as an underpass with topography sloping away from the arch and the tree line connecting both sides of the highway. Is there, next slide. And a little deeper, thinking about nighttime conditions and vehicle lights and noise, we use berms and vegetation to offer protection for wildlife use. And again, this is our spirit animals in the upper right, one of Dr. LaPointe's bobcats. Next slide. And from the wildlife perspective, a crossing at this location reads not as a highway, but a continuation of the land cover. This is where the aesthetic quality of the beveled edges really shine. And once again, thinking a little deeper about monitoring and security of such a bridge, we're working in conceptual details on cameras, motion sensors, trip counters, so success can be measured. In essence, a smart bridge. And also ATV exclusion measures and maintenance access issues are part of our planning. And building on the lessons learned from existing precedents, it's widely accepted that wildlife crossings function most effectively as part of a network of crossings. In any way we slice it, there's a clear need for whole systems thinking when it comes to reconnecting our landscape and making the Scunnamunk Eco Bridge an achievable first step and model for the region. And we've actually looked at a series of crossings here with 2 potential locations south on 87, along with a series of bridge replacements and daylighting of streams for underpasses would really create a network of crossings through this totally bisected landscape that the New York State Thruway traverses. There you go, Bill. Bill, you want to close?
That's it. I'm closed. That's our project. Thank you, Peter.
Great. Well, thank you both so much. That was really fascinating. And we have about 9 minutes for questions. So please go ahead and drop those into the chat and I will read through them. A couple came in during the presentation, so I'll just start there and we'll kind of see what comes in. The first question, let me get to it, comes from Ariel Schwartz, who asks, could wildlife tunnels be built underneath 9W in the Thruway? And so maybe this question gets at, what other types of possible corridor details are there and why did you select what you selected?
I'll be happy to start answering that from a biological perspective. The ideal combination has been shown to be underpasses and overpasses to really establish ecological connectivity. Some organisms prefer one, sometimes strongly, to the other. In this area, there are some culverts, and as Peter mentioned, we would propose to enhance those for wildlife use. to really create a permeability zone rather than a single connecting structure. But in general, large-scale landscape bridges provide the greatest amount of habitat connectivity, as shown by examples around the world. And so that's why we propose at least one of those. On Route 9W, there are some existing culverts. They're really problematic, but we've started discussions with the DOT about perhaps some of those can be enhanced as well. Otters in particular are trying to cross to get up to the forest and down to the Hudson River, and there's a lot of mortality. So we hope to work on both sides. And again, a lot of these improvements have been done in different places around the country and the world. New York State needs to catch up.
Great, thank you. We have another question here from Elise Arnaud-Brill. She asks, what are the impacts of highway noise and volume, as well as recreational trails on animal use?
I know some of the literature on that, so I'm happy to chime in. Yeah, certainly a lot of animals exhibit hesitation to be near the highway. That's why we've got berms to kind of shield the animals on the overpass from, to some extent, from sound and noise as well. And what was the second half of that?
Oh, apologies. The second half is highway noise and volume, as well as recreational trails, and so probably human activity.
Right, exactly. So, there's varying results on how human activity impacts wildlife use of crossing structures. There are occasionally negative results shown, and that's one reason why we propose a really wide structure, giving predominance to the wildlife. And ATV control is going to be essential in this area. Some smaller crossing structures that have been designed that are really overrun with ATV use have been shown to really dissuade wildlife. So we've been working with cadets at the West Point Military Reservation actually on ATV exclusion design. And that plus a moderate amount of fencing, in general, a small amount of human foot traffic has been shown not to negatively affect most species on these crossings. But we give the people a really nice wide crossing on one side and the wildlife an even wider passage, mostly for their use on the other side.
Yeah, I would also add that there's a time consideration here where people are usually would use this bridge during the day. And a lot of, as you saw, a lot of the activity with the wildlife, especially the carnivores, are happening at night, especially movement. So.
Great, thank you. I've seen a couple of other types of questions coming in, but just before we sort of wrap up this topic, there's a question that builds on that, which asks, can you have corridors that are proximate to human development, which I think you're sort of getting at, but sort of what, how much development is too much maybe?
Yeah, that's got to do with the sensitivity of the wildlife species in general and their adaptability. Coyotes have been shown to adapt to almost anything, and even the worst culverts under the highways will occasionally see raccoons using them. Some of your more sensitive species are going to stay away, but we get surprised occasionally. Scott has found fissures right up against Highway 84, and we have a young bobcat we collared and tracked for a while who crossed back and forth over the busy thruway many times. She must have been born there at that area, and it's kind of scary, but I don't think just because we've got a developed area, the animals are not going to use these. They have been returning, trying to return, and with connectivity, I think we can coexist with almost all of our species.
Great, thank you. All right, so kind of focusing back a little bit more on carbon sequestration, there's a question here from Eve Hunt. She asks, the sequestration numbers for Black Rock Forest included trees and forest soils. How did you arrive at carbon estimates for soils, and what sources did you use?
Yeah, carbon estimates for soils are really tricky, particularly in our landscape with the huge amount of rock cover, shallow bedrock from place to place. We formerly relied on estimates provided by U.S. Forest Service and people who've done soil surveys over large areas. Since then, we've done some sampling of our own soils, the major forest soil types in Black Rock Forest, sampling by horizon, figuring out bulk density and the rough carbon content per soil layer, and then extrapolating over the forest. So we think our soil numbers have gotten a little bit better, but boy, it's really, really tricky. And if anybody knows better methods, I would love to know about them.
Agreed. Great, thanks, Bill. All right, our next question here is from Jim Lyons. The question is, the recently passed infrastructure legislation provides millions of dollars for connectivity projects such as you described. Western states are capitalizing on this money now. What can we do to get New York and New Jersey DEP to work with their transportation agencies to go after more of these existing federal funds? Any thoughts there?
That is a great question, and we are actively working through those discussions now. Luckily, we've been able to be working closely with New York State Parks and the New York State Thruway Authority, who have had conversations with New York State DOT about access to funding, not only existing federal funding, but then there's a new program in the infrastructure bill specific for wildlife crossings. Rules are still being written on that new funding, so it's debatable when that money will flow, but ultimately it will. And we're really trying to position this project to get it to a point in design where we may qualify for those kinds of fundings or be able to help the state agencies qualify. So active open discussions on funding and ultimately who is going to build this crossing.
Great, thank you. And we have time for about one more question, which is exactly what we have left in the chat, which is perfect. So I will ask that. And then of course, if there are any other questions that come up, there will be time at the end of, after the third presentation, there'll be additional time for any open questions, just so everyone knows. Okay, so our last question for Bill and Peter was hunting a component of deer management at Black Rock Forest?
Yes, hunting's been a component of the management at Black Rock Forest for about 40 years, I think. Specifically, trying to lower the population has been emphasized for 25 years, especially by trying to take does. When hunters only take bucks, it doesn't have much effect on the population. The hunters have been amenable to this. Our take is roughly 50-50 nowadays, and has been fairly well sustained even despite lower hunter numbers. I think the ones that are left are to some extent more successful hunters. They're taking does. We think it's a significant factor, just not the only one. And we're fortunate to have a DEC that's come around in permitting to providing more doe permits in areas where there's clearly problems like lack of forest regeneration. So we get additional doe permits every year from the DEC.
Great, thank you so much. I'm going to move us on to the next topic, but again, there'll be more time for questions, so thank you again, and we will hopefully have more time to talk at the end. So our next presentation is by Tom Almendinger, and he's going to drill down a little bit further into our theme and address the impacts of deer herbivory on regeneration and possible solutions to this at a regional scale. So Tom Almendinger is the Director of Natural Resources and Agroecology for the Duke Farms Foundation. At Duke Farms, he has developed and continues to direct a large-scale landscape restoration program on 2,740-acre property that includes a range of habitats for fostering nearly 30 species of wildlife listed as threatened and endangered in the state of New Jersey. His natural resources team hosts a number of applied research projects in partnership with research universities, institutions, private firms, and other foundations around the country. Tom serves on the technical advisory board for the Rutgers University Ecopreserve, New Jersey Invasive Species Strike Team, the Hutchison Memorial Forest at Rutgers University, and is also the past vice president of the New Jersey Wildlife Society. He's also a certified ecologist through the Ecological Society of America. He holds an MS in ecology and evolution from Rutgers University, and his research interests include plant herbivore interactions, particularly between overabundant white-tailed deer and invasive plants, restoration of degraded habitats, conservation of threatened and endangered species, and sustainable agriculture as it relates to habitat and ecosystem services. So today, Tom will be presenting a talk entitled Restoring Forests Through Effective White-tailed Deer Management. So please join me in welcoming Tom.
Good morning, everybody. Since I'm the outlier, I'm in New Jersey, I just wanted to welcome you. Thank you for having me join your group. I think what I'm going to talk about today is very relevant to what you will be experiencing in your areas. We are potentially one of the worst places in the Northeast for overabundant deer, and I'll get into the details of that. As you were told, it's talked to be called restoration through successful white-tailed deer management, aka most bang for your buck. But as Bill alluded to, if we were just focusing on bucks, we'd have no success. We also target breeding age females. Over the last 18 years of management, we began in earnest 18 years ago. And since then, we have a 3-to-1 ratio of doe to buck harvest, and the numbers really show. This is a 1930 aerial of the property. And as you can see, most of the forest had been cleared at this point, and the soils were filled, aka disturbed. The wetlands were drained by our wealthy benefactors to utilize the land better, according to him. And beginning in the 1970s, white-tailed deer populations began to explode beyond our biological carrying capacity. This is a more recent aerial view, and as you can tell, all those beautiful farm fields that were once agricultural lands have been easily developed into subdevelopments and industrial developments to our south. And I'll refer back to the slide before, if you can, I'll head back to that one. Let's see. If you look, there are only several pieces of forest land that existed in the 30s. And those are the areas that we have chose to focus most of our restoration efforts forest-wise, because of that lack of forest disturbance and soil disturbance. Just a kind of example of where we are, and as you know, we are in a very highly developed area of the Northeast, if not the United States. We're probably the most densely populated. We are the most densely populated state in my entire life, throughout my entire life, and in one of the most densely populated counties. So if you look below the M, E, and part of the O is Duke Farms. And as the years progressed from 1972 to 2001, you can see how urbanization has occurred around us. So we've become sort of an oasis, but we do have some connectivity to a very large forest called the Sourland Mountain region, which is the green section to the southeast of us, southwest of us. And we are working on corridors to Bill's talk. We do not obviously have the predators that Bill might have. We have very limited black bear. We have wanderers. We do have a very abundant population of coyotes, which do help us with some of our management. So where do we begin? Before I started 20 years ago at Duke Farms, the staff was requested by Miss Duke at the time to, over the decades, to feed deer during winter months to bolster their populations and to keep them healthy. There was never any real deer management had ever occurred on their property. And I heard Bill talk about 30 deer per square mile. I would die for 30 deer per square mile. We started with, in 2004, with 250 deer per square mile, and some areas were higher. Deer were beginning to suffer from malnutrition and beginning to die. You know, all these cascading effects when I first started there were very noticeable. The habitat values were horrible. Common species of fauna that were lacking due to degraded habitat, like wood thrush, ovenbird, and small mammals and salamanders, were non-existent. It looked like a Serengeti, honestly. Some of the large 200-acre fields we had, you could glass over 200 deer from one site. And as a 4 square mile property, we shouldn't have more than 60 deer, as far as that 15 deer per square mile target goes. So 250 per square mile or 1,000 deer was quite overabundant. So this is just a snapshot I took one day out in a large field, and there's 30 deer in about 5 acres. And that's enough for about half of our property, about 2 square miles, and that's on 5 acres. Stephen Horsley is a forester from Western Pennsylvania, and this is a great quote. This is not a new one, but it's fairly recent. The current density is producing devastating and long-term effects on forest. Foraging deer, vacuum up seedlings, highly preferred species, reduce plant diversity, create near monocultures, and he's just talking about vegetation at this point. There's whole other cascading effects that happen once this happens that I won't go into, but there are many. And these are just some photos showing you what the browse looked like prior to us doing any deer management. This is actually a winged euonymus, an invasive plant being browsed. And it's very typical zombie geriatric forest with large old trees, zero native understory, no advanced regeneration. It was a dying forest, and we were in big trouble. And as diseases come in, like emerald ash borer, which we are being devastated by currently, bacterial leaf scorch in our red oaks, not doing anything would have been devastating. So fortunately, we almost 18 years ago, we began to do something about it. Again, this one photo shows, our major issue, our Asian invasive species, Japanese stiltgrass, Japanese barberry, wineberry, very common when I first started. In 1999, we installed an exclusionary fencing around about 640 acres of our property known as the park. At that point, there was deer inside, so I wouldn't necessarily call it exclusionary fencing, but at that time, the goal was in the future to figure it out. But we did 640 acre deer exposure, and within that 640 acre deer exposure, we did a 30 acre deer exposure, which we did remove the deer from. So we had various ages of things to research. I won't go into the details, but for a while we did some trap and transfer, over 300 deer prior to being able to do lethal measurements. And our populations still continued to grow. So we were not keeping up with the fecundity of the deer, which is really hard to do, as anyone who's ever managed deer. So in 2004, we were finally able to convince our board to allow us to take lethal action. And we had a saturation hunt, management hunt with 70 hunters. We also used a sharpshooter, professional sharpshooter inside that 640 acre exposure, as we had staff members living on site, and the sensitivity of all that. We wanted to make sure that we were temporarily separating people and rifles. So we used a sharpshooter for that, and he removed, and his crew removed 230 deer in 3 nights and brought the population down to 0 inside the fence. The 70 plus controlled management hunters we used the first year harvested around 400. So in the first year, we removed over 600 plus deer of that 1,000 deer population. We use as many tools as we say. That's why we call it integrated plan. Here in New Jersey, we have very liberal bag limits, take limits. We have unlimited doe permits. We have no restrictions on how many does we harvest. We use agriculture depredation permits. Since we have a large agricultural component, we are allowed to get permits to shoot deer off season, off hours, and in the dark, etc. And one of our most successful things that we do to bolster our controlled management is we do organized deer drives every season during shotgun season, in which we probably harvest nearly 40% of our take every year within a 3 or 4 day period. So they're highly successful. One of the things I do for the team is I actually set harvest goals based on, we do a FLIR. For the first 15 years, it was with a fixed wing plane. Now we're using drones, much cheaper, just as effective and just as accurate. But basically, I put the population into this demographic thing that I vetted with several wildlife professionals across the country, and just to get an estimate of how many deer we want to harvest a year, and just to keep everyone to keep in mind, just to maintain a status quo of herd size, you need to reduce your herd by 40% of your start pre-fawning estimates. So I usually set the target at 50 plus, and we usually do, over the last 10 or so years, we've been able to achieve that. Just a graphic example of what our population per square mile looked like over the years, from beginning to, I guess, 2 years ago, where we're down to 23 deer per square mile. Okay, enough about the deer management. What the heck happened with the vegetation? That's what we're really here about. That's why we're managing deer. We're not managing deer because they're evil. They are part of the system. They do provide services for the environment, but at obviously much different levels than they are currently. And this picture is a beautiful example of what our early spring forest looked like back in the day before deer management. The carpet of ranunculus ficaria and barberry and all other bunch of nonsense. We studied the vegetation in two different ways. We studied it locally, and then we compared it also to historical data, which I'll get into later. But this first part focuses on Duke Farms itself. I'm not going to go too much into the details. I did share the paper with Scenic Hudson, and that's on some of the sites if anyone wants to dig into it deeper. If I don't really want to run through what the methodology was. Basically, we're measuring. I'll have to go to the next slide. It's probably easier to see. The bottom left is a forest seshi board. We call it a seshi board. It's very similar to what they do in water quality. Kind of basically, it's within the browse zone of a deer, and we look at invasive versus non-native, native plants versus invasive plants in those cells. We basically take a point that we return to every 3 to 5 years. And we go in the 4 cardinal directions and we measure those little I can't remember the size of the plots, but in each cardinal direction we do both of these measurements and record the data. And this picture is taken in the same exact location, very manicured, kind of in heavily browsed and manicured area on the left. You can see the advanced forest regeneration. That is not, no planting was done. This is all just the seed rain. Okay, so here we go. It's the nitty-gritty here. The native species, woody species. This is we began the vegetation surveys in 2008. Unfortunately, we couldn't get our act together in the first 4 years to begin this. We had to develop a system for doing it. So it took us 4 years to develop it, unfortunately, but we did miss 4 years of data and it made some of the work kind of sticky, but we figured it all out. And you can see here the native species, woody plant species in the exposed areas increased from 23% to 70%, an average of almost 5% per year. And even on the exterior, similar to what Bill saw, there is an increase, but a much slower rate. 6 to 26, so about 2%. Non-native species also increased in the exposure and outside the exposure, actually at a higher rate in the exposure, probably due to the least amount of deer, less deer in there. And these increases were primarily from multiflora rows, which are browsed by deer, believe it or not, even though they're thorny as heck. They do browse quite a bit of the young growth and the shoots. The next slide shows graminoids. Am I on the right slide? Yeah, it's graminoids. So native species pretty much stayed the same inside and out because they're not preferred browsed by deer. So you would expect that not much would change, even with the different deer densities. However, the non-native grass species, you'll see in the exposure decreased from 52% to 25%. And that decrease is almost primarily from the advanced, the abundant regrowth of young trees and shrubs, which creates a huge shade barrier for the growth of Japanese stiltgrass. You need I have a former friend that I went to graduate school with who studied Japanese stiltgrass in the region, and some of his studies showed that you need up to almost 90% shade to eliminate stiltgrass. So you need a pretty dense regrowth, but you can see that red curve sloping down, and that's actually great because we do not manage stiltgrass. It's almost impossible to manage stiltgrass. But if we can use ecology to manage stiltgrass, even the better. No herbicides, just by managing the deer and allowing the forest to function properly, you can get some control of these invasive plants. Herbaceous species, slight uptick inside the exposure. A slight decrease, as you would expect, maybe on the outside. And non-native species in the exposure also went up, again, because less deer, exposure. And the reason that the data shows that primarily the increase in these Japanese honeysuckle runners. As a deer hunter myself, I know that in the wintertime when things are getting rough for deer, if you can find patches of honeysuckle, you'll find deer browsing it. So that's the reason for the uptake in that inside the deer fence. And this is a graphic kind of depiction of what you see in our forest. This is a young developing forest of hickory seedlings and other things with stilt grass underneath, as I said earlier. And if the next slide shows a more advanced age growth of those plants and some hickory and other species, and you'll see the stilt grass has been virtually eliminated at this level of shade. Again, some more advanced regeneration choking out this Japanese barberry, which is now dead. I've gone back and taken the picture. So my point of showing all these pictures is that, yes, active restoration and invasive species control is important, but it won't ever level off unless we do something about the deer management, the deer population, and allow the natural forest regeneration to help us along the way. There's that picture I showed you earlier, and what happened once we removed it and the deer were removed. Unfortunately, most of that regrowth you see on the right side is young ash seedlings, which may or may not survive the onslaught that we're currently under. The second part of the data that we collected was to compare across the region. We worked with Dr. Jay Kelly from a local community college, also someone who I went to graduate school with, who's one of the leading ecologists in the state studying these things. Him and his students recorded stem density and heights of tree seedlings and saplings and compared these with historical and regional data sets as benchmarks to gauge the extent of forest recovery at Duke Farms. So the initial set of data was collected in 2016 and 17. 5 plots were inside the fence, 5 were outside the exclosure. You can see the dark blue, the categories from small seedlings to large seedlings. Small seedlings are less than 30 centimeters tall. Large seedlings are greater than or equal to 30 centimeters tall and less than 2.5 centimeters in DBH. And saplings are 2.5 centimeters to 10 centimeters. So it's a scale of small to large, left to right. You can see that small seedlings are much higher than the exposure than the, not much higher, but higher than the regional, current regional, but much lower than historic. And then if you look at the large seedlings where we kind of have this like snake eating a prey kind of bubble moving from left to right, if we had done this earlier, we would have seen that dark blue bar much higher. But now we've advanced several years and we're into the next size class, which is large seedlings. And you can see the exposure versus the regional, the Piedmont regional to the left of it exceeds, that's the current situation around us. It's even beyond the historic Piedmont and all the historic sites. So we do have a huge growth of this class, the seed class, this tree class. And even the outside the exposure, you can see it kind of almost is comparable to historic Piedmont. And when we say historic, we're referring to the most of these data were collected from regional data sets before deer were a problem. And the saplings you can see obviously have not caught up. We're not gotten to that size class yet, but the next slide will show kind of where we are a couple of years after the first initial setup. You see that how many more small seedlings we have. We've now jumped up past the historic Piedmont where we're located, and you can see as it moves to left to right, the size classes are now catching up with some of the historic data. So hunting deer is working when it comes to at least tree seedlings. And this is my final photo that I'll end on. This is a local forest patch that has not been disturbed. They consider it one of the older forest patches in New Jersey, and you can see the full gamut of what we're trying to achieve as far as stratification of a forest vertically from ground up to the large tree seedlings, large trees with large abundant shrub cover. That's one of the problems that we are still seeing at Duke Farms because of the decades of herbivory, of super abundant deer populations. We didn't have any seed sources to replace the shrubs. So we are actively growing native shrubs in our nursery on the farm, and we're actively restoring populations. To give you an example, historic data showed that 40% of the forest in this area was covered by maple leaf viburnum. 20 years ago, I was able to find 3 maple leaf viburnums on 2,700 acres. And the only reason they survived is because they were inside of a dog pen and not accessible to deer. Over the last 12 years, those 3 plants have spread across 7 acres and are now becoming a little bit more dominant. So it's pretty nice to see this slowly happening. But again, my point of it is that, you know, Duke Farms is probably ground zero for, you know, the perfect storm of habitat degradation, a long land use history of disturbed soils, cleared forests, wealthy benefactors who traveled the globe and brought back exotic plants from across the globe, planting them across the property, and never allowed for deer man. We probably were 2 decades ahead of New Jersey having high deer populations. So if we can do it, I'm telling you, anyone can do it, especially you guys in the that have a problem, but not quite the same problem as we have. I gave a very similar talk years ago up in Vermont, and they were laughing at me like, "There's no problems." Like I said, it's coming. You wait and see. If you don't take care of it now, you're going to see maybe not as extreme issues that we have, but you know, it's there. The impacts are there. And with that, I'll take any questions.
Great, thank you so much, Tom. That was really interesting. And I'll just say for myself that I've been reading your paper the past couple of days when I have time, and I'm really enjoying it because I've been thinking about deer management potential for our property. So thank you so much for sharing that.
Great.
We have about 5 minutes for questions, and then we'll have a 5-minute break, which folks can stay and ask questions then too if they'd like, but we'll give people a chance to take a minute. So I will look through the questions that we have now. For you, Tom, the first question is, can you comment on jumping worm abundance inside and out of the exclosures if they were present?
We have not seen those worms yet on our property. Not to say they're not there, but we have not indicated that they're around yet.
Okay, thanks. Do you have any idea if you would anticipate them getting through the exclosure as it's built?
Yeah, I'm sure they'll show up. Everything else shows up at Duke Farm. So we've identified almost 90 different invasive plant species that are naturalized. You name it. So I wouldn't be surprised.
Great, thank you. All right, our next question is from Matt Kennedy. He asks, how often are FLIR drone flights for deer population conducted? And are they relatively accurate compared to other population count methods?
Good question. Just so everyone knows, FLIR stands for forward-looking infrared. Uses infrared technology. Again, the plane or drone or whatever methodology, helicopter that is being used, they fly a transect across the property. We do it once a year. Usually, depending upon, it used to be a little bit more difficult because we hired a gentleman from Ohio to come out with this plane. Now it's a little bit easier. We use a local team to run transects with the drone, which we actually do have been able to do more frequently, 4 times a year. Prior to that, we've done it annually, but this past 3 years we've done it January, February, March, and April before leaf up on our property to see how the populations and where they're hanging out on the property, so we can inform ourselves where we can focus our efforts better.
And Tom, the second part of that question was, do you have any thought on how accurate
accuracy, yeah. Most of the literature says it's one of the most accurate. We did write a paper years ago comparing it to distance sampling, roadside sampling, to trail camera trapping. they all have their uses for a property as large as ours. And not everyone can afford to do it. Obviously, the plane was very expensive, roughly $8,000 a year to do the nearly 3,000 acres. To do the 4 different surveys with the drone, or it says half price. So you can imagine if I did it once, it would be very affordable. But the accuracy in the literature is pretty good, and it's most of the accuracy is within 95% confidence interval. So we feel pretty accurate, and our numbers show that as we harvested and followed the trends throughout the year.
Great, thank you so much. I'm going to group another question with this one before we move into a slightly different topic. Bill Schuster asks, in our less productive area, our threshold below which we get tree regeneration is about 15 deer per square mile. Can you estimate the comparable threshold density in your area?
Sure. I think for tree regeneration, I would say it's probably in that range of 15, but probably we do see a little bit, we have pretty productive areas, and they're probably around 25 to 30. We start to see some regeneration. There's still some impacts for sure, negative impacts, and slower, obviously, than inside the fence, where it was deer free first until Hurricane Sandy, and then we had 87 breaches in our fence, and we've had a hard time managing the deer because it's so dense inside there. But the average density inside the fence is around 10 to 15 per square mile. Whereas outside it's anywhere from 25 to 35 on a given year, depending on if we have EHD around or whatever. And the regeneration is there, but it's not quite as robust as inside.
Great, thank you. Another question from Elijah Goodwin asks, can you comment on the management of invasive species within deer exclosures? And I'm interpreting that probably as vegetation, Elijah. If that's not correct, let me know.
Say it one more time. I'm sorry.
So can you comment on the management of invasive species within deer exclosures? And I'm assuming that's plants.
Sure. Like I said, there are some impacts by having less deer. We are seeing an increase in certain things like honeysuckle and multiflora rose. But I think it gives us better areas to target. Obviously, we see most of this stuff on edges or in canopy gaps where it's more of an issue. We are beginning to gain ecological control with the shading and a lot of those species. We do actively focus on EDRR species, early detection, rapid response. So those are species that are new either to the area or to the property that aren't established, and we want to get rid of those before they do get established, or whether they threaten conservation targets is where we focus most of our effort. I have a very small restoration staff of about 2, so and we target what we can.
Great, thank you. So this is going to be the last question before the break. There is one more after this, so I'm happy to stay on and facilitate if anyone wants to hang in. But for this last question, it's sort of relevant to your last comment there, Tom. Do you have any analysis of the costs of running your program, deer management, population measurements, field inventories, et cetera? Can land trusts or small land organizations afford this kind of management, or is it very expensive?
Sure. If you're just speaking of management itself, the actual deer management, not the tracking of vegetation, I can give you a better estimate of that. But so for deer management, we are allowed to bait in New Jersey. So we do provide bulk corn for our hunters, which cost us roughly around $2,500 a year. The FLIR probably cost us around $4,000, which you don't have to do. There are cheaper methodologies if you have volunteers to do distance sampling and those kind of things and road counts. But you shouldn't go into it blindly, I think, and just manage deer without knowing essentially kind of what your population level is at. But I think land trusts can do it, especially we're doing it at a very large scale, right? 3,000, almost 3,000 4 square miles. We're bigger than some towns in our county. So most land trusts are probably either a bunch of little parcels, which makes it a little bit more challenging because you're not able to kind of handle what's going on around your borders. We even see that on a large property where land that abuts us is not being properly managed for deer. They're buck hunting, which doesn't really help us at all. but I do think it's affordable. I mean, I think there's plenty of land trust in New Jersey and local communities like Hopewell Valley Open Space is doing a town-wide program. It's not quite as successful as it could be because there's so much, when it comes to private land ownership and different land ownerships, it becomes a little bit more challenging. I have a unique situation where as does Bill, where we can kind of focus on our own properties, which is a very different thing. But I think it's definitely, I don't think we should not try. You should not try it, even if you don't have all those bells and whistles with FLIR and paying for bait. I mean, a lot of places charge hunters to hunt. I'm one of the few that doesn't in our state.
Great, thank you.
You can offset those costs, I'm saying, with fees or volunteer hours or whatever, both.
Perfect. So thank you for that. That question came from Spencer Meyer, actually, and he just asked to follow up. Could you repeat how many square miles you said your property is?
4 square miles.
Sorry?
4 square miles.
Okay, thank you. All right, so I think we should take a break there. We only have 1 more minute before we're supposed to be back. So I want to give people an opportunity to jump off and then we will meet back here. Heather, shall I give us a couple extra minutes or do you want to come back at 11:15?
Yeah, it's fine to give an extra couple of minutes. So it is 11:14. So come back at, let's say 11:20.
Okay, so thank you to Tom, Bill, and Peter for those great talks before. That was really interesting. And now we're going to move into a slightly different aspect of our topics today. And so we will be welcoming Spencer Meyer, Dr. Spencer Meyer of NCX. He will be speaking today about the Natural Capital Exchange Organization and their carbon marketplace opportunities. And I won't go into it any further because he will be better at explaining it. But Dr. Spencer is the Director of Science, Strategy, and Stakeholder Engagement at NCX. Spencer is responsible for working with stakeholders to link the science and business of natural capital markets. He also leads the company's development of new ecosystem service credits, including biodiversity, habitat, water quality, and wildlife mitigation. Spencer is an innovator and a leader with 20 years of experience working collaboratively with NGOs, government, private sector, and academic partners to solve natural resource challenges. And he is also the co-founder of Seabago Clean Waters, an advisor to conservation NGOs and private foundations, and a frequent speaker on forest management, watershed protection, natural climate solutions, conservation finance, and partnership development. He's previously worked with the Hystad Foundation, Harvard Forest, Yale School of the Environment, University of Maine, the Nature Conservancy, and he has a MS and a PhD from Dartmouth College in Forest Management and Sustainability Science from the University of Maine. So please join me in welcoming Dr. Spencer Meyer.
Hello, everyone. Nice to be with you here this morning. Pia, Heather, and Ned, thank you so much for the introduction and the welcome, and most importantly, the invitation to come speak with the group today. I'm really excited to do this. First off, I'm based here in Guilford, Connecticut, where I live. NCX does work all around the country and increasingly outside the country, but I'm based here in Connecticut, so not too far away from many of you. And the original reason I think we started talking about this panel idea was because some of the work I had done at the Hystad Foundation, which is based in Connecticut and does work all around New England. So I just want to briefly say kind of how I got to do what I'm doing now based on some natural climate solutions work we had been doing at the Hystad Foundation with a bunch of partners around New England. We had been following the state policy agendas for climate acts. Most of the states, although not all of them, in New England have ongoing policy and stated goals for reducing emissions. And there was a lot of discussion and conversation, but not a ton of action in some cases. And we were really interested in understanding, well, what is the opportunity? How big is the opportunity to do natural climate solutions in New England in particular? And of course, a lot of what is relevant in New England is so right over the border in New York and New Jersey as well. And so we did this study, and it is still forthcoming. It should be out from Hystad in the next month or two. That looks at and comes up with what we think is the first estimate of the forest-based natural climate solutions for the New England states based on additional wildlands, forest conservation, changes in forest management, and urban forests and forestry. And so we're all excited to see that come out, and I think we'll have a lot of policy relevance as well. it was during that work, doing that work, that I first got excited about and interested in the evolution of carbon markets, carbon credits, and how they've evolved a long way since the early days. And I'll say a little bit about that earlier. And it really became apparent to me that there needs to be an incentive in carbon markets to pay landowners to change their current behavior. A lot of the existing programs have really been focused on paying landowners to kind of for what they have already done, and then to more or less keep it that way for a very long time. And there are a lot of important reasons to do that. But for me, and what I saw was really about, we can change behavior in the near term that will have much bigger long-term upside to that from my perspective. And it just so happened NCX, the Natural Capital Exchange, have been pioneering harvest deferral carbon offsets over the last couple of years. And this was built on almost a decade of climate technology, data-driven forest remote sensing and inventory services that they had been providing with large landowners throughout the US. And so I want to tell you a bit today about the program that we have at the Natural Capital Exchange, or NCX. And then I'm going to bring it back to the wildlife, because we are called the Natural Capital Exchange, which is inclusive of a lot of, or really all, ecosystem services. And we have started with carbon, but we're quickly moving into other ecosystem services as well. And I'll talk a bit about that as we get going. Okay, so by now, probably everyone's pretty familiar with the IPCC goals for the world and the math that adds up to us needing to reduce our emissions by about half by 2030 and getting to net zero by 2050. And there are lots of different pathways, and there's many, many examples of this graph here. But the bottom line is we need to stop putting stuff into the atmosphere. And we also need to negatively remove carbon from the atmosphere. These are the negative emissions that are at the bottom there. So we have to both stop putting as much in, that's lowering our current emissions, and then we need to remove some of those former emissions from the atmosphere. And all of you here know that forest and agriculture in many ways, but forests in particular, are a really great way to do this. They're biologically wired to suck carbon out of the atmosphere. But as we know, the devil's in the details. And what's most important for solving this problem is making sure whatever you are doing is additional to whatever we were doing before, because this graph, the peak there, already assumes we were doing everything we had been doing before, because that's how we got here. So if we only count up how important our forests are today, and we say, oh, look, we did a good job, our forests are sequestering a lot of carbon, we are not able to change or bend that curve. And so we really need to focus on changing what we're doing in a positive way to get to carbon removal. So here are the forests of the United States. 43% of these are owned by family forest owners. That adds up to a little over 10 million acres across the US. And the reason the different categories here are important is because the kind of management activities and objectives that all these different classes, whether they're public landowners or large industrial, private, or family forest owners, the kinds of management that they all undertake varies considerably. And so if you want to incentivize landowners to do something differently, you need to understand how they work now and what's in it for them from an economics perspective to make all of that make sense. So here are the forests of the United States. 43%, remember, are family forest owners. The problem with the first round of carbon markets, that was the California Air Resources Board program, which is quite old at this point, was that the economics of doing those projects and the inventory and upfront costs were really a barrier to entry. And so in effect, you couldn't really do carbon projects on fewer than about 5,000 acres. And that varied a little bit by region, but on average, 5,000 acres was kind of a benchmark for that. And that left out most of the family forest owners in the country. So by our math, 61% of the acres in the US are under that size, under that 5,000 acres. And so immediately you have left out a lot of people. So one of the first principles of NCX was to democratize the access to the carbon markets, if you will, through the voluntary carbon markets. And that was really important to be able to get smaller landowners to be able to participate in the market. The second key ingredient in NCX, so the first is allow smaller landowners because we want to get to scale to make a big difference. The second is to make sure the quality of the carbon credits that we're producing with our partners meet certain criteria that we'll talk about. There has been quite a bit of bad press at this point over the years about legacy forest carbon projects, where they have and have not made a difference, what the specific shortcomings were, and how the field sort of needs to evolve to make sure we're all creating high quality carbon credits that really are making a difference. It's at the end of the day, if the atmosphere doesn't feel the change, they don't really matter. And so organizations from private landowners to academics to NGOs to sort of international watchdog groups have really been shedding a lot of light on the importance of quality in the carbon credit markets. So what we are doing at NCX is really sitting in the middle as an auction or a marketplace between individual landowners who are getting paid in our program currently to not cut their trees for 1 year. That's what we call the harvest deferral method, and I'll say more about that in a minute. And we are bundling the carbon we can generate from that across a large portfolio of hundreds and thousands of landowners. And we are turning those into carbon credits, which we are then selling primarily to corporate sustainability programs who have their own net zero commitments. Now, it's important to remember that it's early days in the net zero commitment world, in that a lot of the need and the supply for credits will come in future years. It's not happening immediately, because it's really important for these companies to be focusing on reducing their actual emissions. Carbon offsets can never be at the expense of reducing emissions, direct emissions. They need to be additive to that. And so they are part of a portfolio, and they should be a relatively small part of the overall portfolio. So that whole industry and understanding of the ratio of those two things is really evolving as we speak. And so the supply, the demand, excuse me, for carbon credits from offset programs is expected to grow rapidly in the next decade. So the quality I mentioned about carbon offsets really comes down to these three, and there are other factors, but particularly these three: additionality, permanence, and leakage. Additionality is what I said earlier. The thing you do that you get paid for has to be on top of what you were doing already. Otherwise, the atmosphere is not going to see any difference. The permanence is, does the activity have an effect on the ground, and is that effect lasting? Now, often 100 years is set out as sort of like the default idea of what permanence means, but of course, permanent is way longer than that. Now, I said a minute ago, we are doing these 1-year harvest deferrals, and I'll get into in a little while why that benefit is permanent. It has to do with the act of delaying a potential emission and the time value of the damages we expect in the future associated with climate change. And then leakage is, well, if I pay this landowner to do something on the left, but the neighbor across the street just harvests more to satisfy that same market, well, that's leakage. And you haven't really affected anything. And so carbon credit systems need to address all of these in various degrees. So NCX's core technology was built when the company was called Sylvia Terra. Our founders, Zach Parisa and Max Nova, are in this image here, showing the first map that they built, what we call base map, that models it and estimates the amount of carbon and the individual trees and species on every acre in contiguous United States. So that adds up to 92 billion trees in this base map data set. And this is at a 30-meter resolution. It's a combination of remote sensing data and forest inventory analysis data, and then more localized ecological data that all come together and create this uniform surface across the US. And this was developed through a big partnership with Microsoft's AI for Earth program. All right, so that's the base map. Now, how the program actually works is that we do an initial property assessment using base map. As landowners come to our platform, they can put their property on the platform by clicking basically and drawing a polygon on our map of where their forest is. And then our data science team uses our base map to produce an enrollment report for that property, and it estimates how much carbon is there now. And then we have what we call our baseline model that estimates how much carbon would be at risk if that landowner chose to harvest their property, or more likely a small portion of their property in any given year. That baseline model is based on local harvest demographics, mill prices, distance to mills. So really it's getting at, does that landowner even have an opportunity to harvest their property? And for landowners that have no opportunity to harvest their property for whatever reason, because they're too far from the mill, or they just harvested last year and there's no timber left, or any one of the many reasons, then they're not going to be eligible for our program. You have to have standing carbon on the ground, and you have to have a reasonably high risk that you would, in which we quantify, that you would actually harvest that property. So based on those two things, NCX will come back to the landowner with an enrollment report, eligibility report, and say, here's how much carbon you have on your ground that you could forego. The landowner then gets to make a bid in what's called a reverse auction and say to NCX, here's how much I am willing to receive, how much I will take from you in order to not harvest this year. And so this is the reverse auction, step number 4 here. And then NCX and the landowner together can come to terms if the auction clears, and then the project will officially begin. Now, we are monitoring and measuring the property through our base map and through subsequent inventories, supplemented with on-the-ground inventory as well. This is not only done remotely. There is a subsampling that's done on the ground by foresters in boots, the old-fashioned way. And so we monitor this project at the beginning of the year, and then again at the end of the year. And then we look at the difference between what was there at the start, what was there at the end, and what would have been there had the landowner harvested that using our harvest estimate and our baseline business as usual modeling. And so then if the landowner followed through on what they said they would do, or in this case, what they would not do, then we pay the landowner for that carbon that they kept on the ground for an additional year. Then the landowner is eligible to re-enroll the following year if they want or not. It's up to them. All right, so we create a new project every quarter of every year. So each quarter we invite landowners to enroll their property in our program in the cycle that I just described. We just closed our winter 2022 cycle. We had 1,800 landowners across 39 states choose to enroll. And you can see that map roughly corresponds to where most of the private forest land was in the United States. Those 1,800 landowners own collectively 1.6 million acres that we were able to do in one quarter. So just in the course of a few months, that's the number of landowners that chose to forego harvest over the subsequent year. Now that those landowners are enrolled, we are monitoring their properties, and we will check in with them at the end of the year and complete the transaction for those that have followed through. The estimate of the climate benefit associated with that is 250,000 tons of CO2e expected at the end of that year. All right, so now our carbon credits, we are going through the process of getting certified through VERA, the Verified Carbon Standard, one of the leading carbon offset programs. And we have developed a new methodology based on this annual delay of harvest, and that's going to the VERA certification right as we speak, actually. So we hope to have that done by the end of the year. Now, as I said, I want to get back to the wildlife and some of the other ecosystem services. We have started as a company with carbon because that's where the market has been, and we saw an opportunity to innovate there. And now that we have that underway, we're beginning to turn our attention to some of these others. We have a lot of interest as a mission-driven company to focus on biodiversity and wildlife habitat in many of the ways that we just heard from the other speakers, because of the management problems associated with some wildlife species and the interaction with carbon. But for other species, there is value to society of having them more broadly from a biodiversity standpoint. So it's not only about their impact on regeneration, although that is a very interesting one to us because it dovetails the carbon and the wildlife habitat as well. We also have a lot of interest from our partners in looking at what kind of landowner activities from wildfire risk reduction could generate additional carbon. In the short term, you are likely to reduce your carbon by, say, thinning a forest. But in the long term, if you are reducing your risk of wildfire, there is a long-term upside to the atmosphere from a carbon mitigation, avoided emissions perspective. So we have several initiatives going on in these other ecosystem services as well. Currently, what we have on our impact dashboard is an example of a few different wildlife species, including deer, by the way, that we have mapped in the places where we're doing carbon offset projects and looking at the prevalence and population dynamics of the wildlife in those areas. We are not yet in these species linking them to the carbon outcome specifically, but we are beginning to do that and just hired a new wildlife ecologist to join us this spring to do that work. The coastal marten is the newest species we added to our dashboard just recently. And you can also see some examples of how much the carbon offset projects we've done, what the distribution is by tree diameter and by forest type across the US. So overall, so far in the last 4 cycles now that we've done projects on 4.3 million acres with almost 2,500 landowners with a total expected CO2e benefit of 1.13 million tons of CO2e. So that's what we're doing. And I would love to take some questions and would invite the conversation with all of you. Thank you.
Thanks so much, Spencer. That was great. And you got a lot of questions. So I'll just start working through those. First question comes from Kevin Webb, who works with us at Scenic Hudson. And he asks, does NCX take into account access issues and topography of the property when determining likelihood of harvest?
Yes. So the base map and the harvest risk assessment together use a lot of different factors that predict the harvestability. The ease of access is one of those factors, and this is part of the sort of improving model. So as we do more properties and the data get better, things like that improve over time. So we are incorporating that to some degree. Very fine grain like issues that an individual landowner would have, we wouldn't have access to information around that. However, we do talk to the individual landowners when we do the projects. And so sometimes we have landowners come to us and say, this is really interesting. Thank you. I don't actually have any plans to harvest. And so we say, well, then you're not eligible for that. Even if our model predicted that they were going to harvest, when we get that new kind of information, we say, thank you, come back another time. So some of the information we do across the whole country, and some of the information is specific on what we receive from the landowners.
Great, thank you. Next question comes from Mike Knutson, who works on our conservation easement team, our land conservation team at Scenic Hudson. Just for background, does NCX work with private landowners that have properties which are encumbered with conservation easements, which may place restrictions on forest management activities?
Sure. Yeah, that's a really important question. And I just thought of another example about the previous question from Kevin. So one example where the local topography, or in this case, the distance to streams matters, is if there are best management practices about riparian zones, for example, and there are in most places, sometimes they're legally binding, sometimes they're just best management practices, we reduce the harvest probability risk in those areas in the same way that you would if you had a management plan. You would be able to harvest less from those areas. So there's a sort of tangible example of where that matters. I'm sorry, I lost the new question though. I was so excited.
No, that's okay. Does NCX work with private landowners that have properties that are encumbered with conservation easements?
Yes, absolutely. But we need to know the details of that conservation easement, because some easements, forever wild easements, for example, tend to already preclude, well, in the case of forever, they do by default, preclude harvest. And so if you are already bound legally to not harvest, you have zero risk of harvesting. And so there's no additionality there. We couldn't possibly do any better than what you're already doing. And so we would not enroll that landowner. That happens to the sort of due diligence process with the individual landowners, where when we discover that there's the easement, we then need to look into the details of it. Importantly, in the very early days of forest carbon offsets, in the first California projects, for example, that was not yet a problem. And there were people enrolling projects and getting paid for carbon. In this case, it wasn't harvest deferral, it was avoided conversions, or improved forest management avoided conversions. That was already in forever wild easements. That got changed after the first few years. I forget exactly, but ours absolutely does take that into account. That said, there still are plenty of easements that are working forest easements that we work with routinely, including land trusts and other landowners that manage their forest.
Thank you. Next question is from Shane Hardy. They ask, how would a sawmill slash probably timber harvesters work with NCX to ensure that they don't encourage leakage or otherwise undermine the carbon sequestration goal?
Yeah, that's a great question. So I mentioned leakage. So there are two kinds of leakage. There is leakage across a whole market, and then there's activity leakage at the finer scale. And the way we mitigate leakage at the fine scale is by ensuring that landowner enrolls their entire property. So a landowner that has 1,000 acres can't enroll the 500 acres they weren't going to harvest anyway this year and not enroll the 100 acres they were going to harvest. They don't get to cherry pick. That is central to our program. So a landowner has to enroll their entire property in that. That has not always been true across carbon programs. It's increasingly becoming true, and it is of ours. Now, there's also broader market leakage across the whole system. And so if we work with landowners, let's say in Mississippi, to not harvest, the overall market, the commodity market for pulp, let's say, is probably going to get that wood from somewhere. So the way we handle that and the way any certified carbon offsets handle that is through standard market leakage deductions that are set by the verifying body. So Vera, for example, has a standard deduction associated to cover from market leakage.
Great, thank you. Okay, this question is coming from Seth McKee. He asks, perhaps I missed this, but what is the source of funding being used for this compensation framework? Are these private sector offsets?
They are private sector. So we sell carbon credits to corporations who are trying to meet their net zero goals, and we use that money to pay landowners to change their behavior.
Great, thank you. Another question here from Jim Lyons. Jim asks, I understand the carbon benefit of avoided deforestation, but could the same concept be applied to avoided development? For example, forest clearance versus conversion to development. Is there a way to capture that carbon benefit for avoided forest conversion in your business model? Obviously, there is a wildlife benefit to be captured as well.
Sure. Yeah. So what I didn't spend much time on is that there's lots of different so-called methodologies or protocols of carbon offsets across all industries, but in particular forests in this case. So there are avoided conversion protocols. There are improved forest management protocols. Ours is the one we are working on now, our first one, and we have others under development, but our first one is a harvest deferral. That is delaying the harvest in a managed forest, because we know we have a strong ability to measure and track the additionality associated with that. One of the concerns that the industry has had broadly about some of the other types of avoided conversion is that there's not a strong way to say what would have happened had you not paid the landowner for that. And there have been many examples where land that was already protected from development in various ways was paid to not convert. And so there's been a lot of questions about, are you paying for landowners to do things they were doing anyway? And that's the question about additionality. So with any one of these methodologies, or whether it's avoided conversion or changes to forest management, you have to have a strong, robust way to understand what that additionality would be. So that's something that is important to us. We won't develop a new methodology if we can't figure that part out first.
Great. We have one more question here. How is the ownership of properties determined to avoid fraud? Is the title pulled on each property? It's coming from Kevin Webb again.
That's a great question, and I'm not sure I know the answer to that. I can tell you we have a whole landowner team that does pretty significant due diligence. I've seen a lot of examples that, for example, on the easements, right? We need to see the easements, actually see evidence of those easements. I don't know the degree to which titles are pulled. I can't answer you there. I'd have to get back to you on that.
Great. Thank you. All right. Well, we have about 8 minutes left for discussion, but I wanted to just open up the opportunity for folks to ask questions to any of the presenters or bring up anything else. I still have questions coming in for Spencer here. So I'll just keep working through those, but I do want to give people an opportunity to ask other questions as well. So if you would like to ask a question to another presenter, please feel free to use the raise hand function, which is a little hard for me to see, or just put it into the chat and just let me know who you're targeting, or if it's just a general question and someone can take it. Right. So Spencer, there was a question that came in right before I said that. So from Helen Marsh, given the impact of deer populations on forest health, how are you considering this issue?
Yeah, deer is a really interesting one, and that's why it was so fun to follow the presentations earlier. And that is why I asked Tom the question about how much does it cost to do that? So on our impact dashboard, we have white-tailed deer as one of the species that we have mapped. And depending upon who we show that to, sometimes they come back with a like Bambi, warm and fuzzy, we love critters, that's awesome perspective. And sometimes they come back with a, oh no, deer are ruining our forest perspective. And as we heard, it all depends upon where you are and what the herd is like and how bad the impacts are in your forest. So you can imagine if you are starting to try to understand how changes in management behavior, in this case, everything Tom described, there's a carbon benefit associated with that, right? Tom showed us those graphs that showed that small seedlings, large seedlings, and then saplings over time are starting to go the direction, all us ecologists want them to go. And so that's great. And there's a carbon benefit associated that would not have happened had it not been for that management. So, and we are starting to do this kind of thing. We have not done it in the way that I'm going to describe conceptually, But you could imagine, you could understand what is the economic inputs it takes to get a landowner to do those things, just like Tom described. You could go, and I think Tom has gone the next step and said, what is the carbon benefit associated with that increased recruitment into the sapling and eventually mature tree class? And you could calculate the cost it would take to generate a certain amount of carbon after, let's say, 10 years or 15 years or 20 years. So that's the kind of market making we want to be able to do in between. And so that's why we're starting to move in some other species. Now, in that case, it's one that has a direct link between the carbon and the wildlife. We have other species that society values for lots of other reasons that maybe aren't about carbon. And so we want to be able to do that also. But moving into species where there's a carbon link is a strong next step.
Just to give everyone a heads up, we've been working with Rutgers University studying carbon impacts to our land management over the last 4 years. And so we will have some of the data soon, I would say, over the next couple of years to understand the differences between the impacts that deer management is having on forest sequestration of carbon.
Great, thank you both. So I have a question that is a general question. So you can decide who would like to take it. And also if anyone else on the call has expertise and would like to share as well, this is an open question. It comes from Eli. Eli says, there seems to be a dearth of leadership addressing the issues of deer overabundance in New York. What organizations or institutions are actively working to address this issue on the state or federal level and lobbying NYDEC or other state wildlife agencies to modify their deer management objectives to actually promote forest regeneration rather than mollify hunters who want to maintain the herd or see more deer at the expense of ecosystem health? So anyone would like to tackle this question?
Speaking as someone who's been involved with kind of more local level deer management, I would say in my experience, the pushback is not so much from the hunting community, but from the animal rights community. So at various community meetings around local deer management, there's a lot of pushback, and it's very vocal, very activist pushback, and that's quite frankly scares a lot of people about making good deer management decisions on their property. So I think that's definitely a challenge. Do I have an answer to that challenge other than just patient, persistent education? Not really. But I'd love to hear others' thoughts on that. But that's something, I've worked with Rockefeller. I've been to T-Town meetings on deer management as well, and there's a very very strong, very vocal animal rights presence at those meetings and very strong objections to the management actions.
Thank you, Elijah. Any other comments? I'm curious. I had a conversation with someone at DEC recently about their deer management efforts, and a lot of people were speaking this year about EHD, the disease that was kind of sweeping through the deer population this year. And I know that it was relayed to me that some of the hunter populations in our areas were actually concerned about the decrease in deer because of the potential impacts to hunting, and so they didn't want to hunt this year. And so it's an interesting balance between the sort of the ecological incentives and also hunter perspectives. And Tom, I see you unmuting, so maybe you have something to add.
Yeah, I have a perspective from New Jersey. It's a little different. I'm not really sure the situation in New York. Our Fish and Wildlife Service is funded by sale of permits and licensing. So they have an unnecessarily, they don't always balance their deer population goals with necessarily the ecological integrity of a patch of land. It's more about making the hunters happy. And to your point about EHD, it did hit us here as well, I'm pretty sure. But literature shows that hunters, once a deer population reaches 30 deer per square mile, hunters perceive that there's no deer in the forest. So that's what we're up against, right? The biological carrying capacity of a lot of areas is 15 deer per square mile or less, depending on where they are. When you have a hunting population that sees 30 deer per square mile and says there's no deer, we don't want to hunt, that's an issue. So I don't, yeah, it's better to Elijah's point, it's a constant education, constant education. But I don't have an answer for New York. Sorry.
Any other thoughts on this question? We have one more question, if not, but I just want to give room for people to add opinions. All right. So one more question here from Ariel Schwartz. How far along is the Schunemunk Eco Bridge? Apologies if I pronounced that incorrectly. Is it simply a proposal, or has the state signaled a willingness to build it? Does it need to be taken up by the state legislature?
Yeah, thanks. That's a very good question. What we've produced with our consultants thus far is just a 1% design. So there's still room for modifications. We're pursuing now more like a 20% design to try to be competitive for especially federal grants. Some state agencies have been directly involved. New York State Parks is a champion of the project. Would really like to see it happen, like to see this happen in New York State. They've reached out to the New York State Thruway Authority, who is on board and who made inquiries with the Federal Highway Administration about funding for these kinds of projects. The proposal also went to the governor's team, the new Governor Hochul's team, who expressed interest. Didn't directly put it into the budget, but I think there's some support at various state agencies thus far. And yes, if we get to the point where we're going to construct the Schunemunk Eco Bridge, even with federal funds, there'll need to be a match provided of some kind by the state, but we found a very welcoming audience thus far on the project.
Thank you. All right, we're at 11:56. We have a few more minutes for questions or engagement before Ned wraps up here. Does anyone have any final thoughts or questions they would like to share with the group? Reflections? All right. Well, thank you so much. And thank you again to our presenters. Oh, I actually do see one more question. Do we have time, Heather?
Yeah, definitely.
This question is from Eli Chitam. The question is, when did New Jersey state wildlife agencies begin allowing such liberal deer management for landowners, and what drove that change? How did they ever overcome the headwinds to more aggressive deer management? If you know that.
Sure. From my experience, I'm only been highly involved with this deer management for 20 years or so. So during that entire time, the bag limits have been set pretty high, and it really depends. We have 8 different regulation sets, which take into account 70 different zones in the state. So depending on where in the state you are, you have different regulation sets. So it gets confusing for hunters. But basically, in areas they consider overly populated, they allow for much more liberal harvests. The Piedmont section of New Jersey is one of those areas. It's highly urbanized, and there's tons of deer running around. When you go to Ridge and Valley province or the Pine Barrens, the numbers are much lower and their restrictions are much different. But pretty much all the highlands and the Piedmont and intercoastal plain have some sort of doe first before you harvest a buck, or unlimited does. They all have some kind of target towards does. And that's been going on for over 20 years. And I think that's because they realized there was such an outcry from conservation groups that the deer were becoming a problem in our area for a long time. I think we were the ones that saw it before almost anybody in the Northeast, unfortunately.
Thank you. Heather, I saw you unmute.
Yeah, well, I just wanted to say thanks. I really thank you everybody for attending. Thank you so much to our presenters today. You know, one of the best parts of my job is I get to hear about cutting edge science and see people's commitment to natural climate solutions. So just wanted to thank everybody. I do have access to the chat, so if there's any questions that did not get answered, I'm happy to download them and send them to the appropriate presenters for answers. So Ned, did you have any final thoughts?
Those are great final thoughts, Heather. Thank you. This is the kind of program that initiatives that NICA is committed to. We saw today some great science, some great land management practices, the learning from that, and then ways of compensating land managers for both carbon sequestration, biodiversity, and the other values, the other ecological services and values that we get from land. So thanks to all. It's been a great set of presentations, great questions, and I hope it's been educational and fun for all of you. So enjoy the rest of this beautiful day, and keep checking the NICA website that Heather has built and is continuing to update with information that may be interesting or hopefully useful to you in your work. So thanks, and best wishes to all.